Hello, 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 y'all. Welcome. Welcome. I'm excited to see you all here. How are y'all doing? Hello, hello. Oh my goodness. So many names. I'm doing well, Greyvox. Hey, Shrey. I don't know how to pronounce your username, ELNGBR. It's too many consonants for me to know how to pronounce that. But yes, I am still home. Have not moved yet. I move on Monday. Elena, okay. Hi, Elena. Lottie, hello. Welcome, first time chat. Where do you live? I live in Michigan, in the United States. Like Tejas. Hi, Dimmer. Hello. Nithya Shribala. Hello, hello. It's Raze. Hello, welcome, first time chatter. Gabine. Hello, hello. Welcome, y'all. For those of you who don't... Wait, where's chat? Okay, so chat's on this screen, but it's not here. Interesting. Is it still snowing in Chicago? I know that here in Michigan, I'm near Detroit. I'm in like an exurb of Detroit. It's been unseasonably warm. It was like 64 yesterday, Fahrenheit. So it might be snowing in Chicago, but it's been very warm here. Give me 1 sec to troubleshoot why chat isn't showing here. Let me see if I screen share. Okay, so it's on screen share. It's just not on my face, which means that if someone subs, I won't notice. Anyone had any good experiences in any sessions thus far? We're on today's day 2, right, of Global Hack Week? What tools are we going to use today? We are going to be using Godot game engine, which is a free open source game engine, works for both 2D and 3D games, which is wonderful. We're going to be using that to, first we're going to create like a fairly basic, now if I do this, nope. Will you give us the links for the resources? I will, Elena. It's good for both 2D and 3D games, and we're just going to be creating a basic 3D game, and then tomorrow we will be implementing an enemy character that will use pathfinding to chase the main character or the player character. So I do that. Okay, that's working. Huh. For the life of me, hey, there we go. Okay. Theoretically, that's working again now. Thanks for bearing with my troubleshooting. So for those of you who have not been to one of my streams before, my streams do look a little bit different than your average MLH stream. I'm lucky enough to have some extra added control One thing is we have a TTS bot that we wrote actually on a stream over a year ago at this point. It's been a while. But you can use the !TTS command before your message and it'll be read out loud by a TTS bot, such as...
Hello, 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 y'all.
Like that. We also have channel point rewards. If you click in the lower left-hand corner of chat, you'll see them all listed there. And if you click on one of them, it will cause a sound effect to play, such as, hello, 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 y'all. That one.
Oh.
Oh, whoa.
Where did you say you'll move?
I'm just... Thank you, Izzy Droid. I'm moving in the same town, just from one place to another. I mentioned it yesterday that I am moving because you'll notice that this view is slightly zoomed in if you've been to one of my streams before. Oh wait, that's focus. If I zoom out a little bit, oh wait, whoa, okay, it's not showing, so I can zoom out. My space is almost deconstructed, just boxes and bags of things all over the place. Yes, Adi, I do remember you. Hello, hello, welcome back. You said you would be here for all of the future streams, so I expected you. Hey Shem, moving is such a thing. I don't know if I'll ever do it again. Oh, yeah. I am not moving right now by choice. It is by like housing circumstances, and I am looking forward to moving to a place with a much better lease and landlord and all that jazz. So I'm looking forward to not needing to move for hopefully at least a couple of years. Hello, Alamit. Hello, Double Edge. Welcome. I'm doing well. So, let me check my notes to see what we have for today. I know that we're implementing a pathfinding AI in Godot. I just wanted to see. Great. Okay. I have, for those of you who've been to one of my tutorial or my streams like this before, you will know that I often like to find a good tutorial by someone who like really knows what they're doing and follow that. So I found one that is 49 minutes long and is focused on people who are completely new to Godot. So I'm going to drop that in chat. And we're going to be following along with this. And because it's 49 minutes, I think we should be able to finish it. If not, we'll get close and we'll be able to finish it on my next stream, which is on the 14th. I've built stuff in Godot 2D only, though. Same. This is going to be my first 3D Godot project, which is partly why the tutorial. But pathfinding doesn't make as much sense in 2D as it does in 3D, because in 2D, there's one less dimensions. There's a lot less to actually find through. I feel like I missed some things in chat. Shem, Ack, landlords. Oh, such a mood. Such a gosh darn mood. I'm living in this, like, I was here as a part of, like, avoiding landlords, I thought. But it's hard to live with people who, like, aren't your landlord, because it gets complicated. So I'm honestly kind of looking forward to having a landlord, even as much as they're awful and terrible. Hey, Green Yoshi, welcome. Great Vox, you have such a cool room. I'll take your old place, LOL. I spent so much time on this stream background. I am so happy with it. I am so sad. The only thing that's not coming with me is the wall and the door. The rest of it is excuse me, moving with me. So it'll look almost the same, but it won't have the pretty purple squiggle that is mostly covered up. But that is the inspiration behind these screens and up there. Adi, it's a bit difficult to be present for your streams. It's almost 3 a.m. in India. Oh my goodness. Yeah, so I say this a lot because this is said at basically every single one of my streams. I admire and appreciate you being here as always, but these streams are recorded, like I think Shem says. Yes, okay. They are recorded, so you can always watch them later, and taking care of yourself and your health and your well-being is always more important. I think that my streams are good. I like how my streams go. I like how everything works. I think I provide a good space for people, but I am never going to say something that no one else has ever said or no one else will say. There's nothing that is essential to my streams that you can never miss. So you can always get sleep, always do homework, talking to 404 even though they aren't here. Greyvox, I built stuff in Godot. I responded to that one. Shem, if you need sleep, the streams, all of them are recorded, uploaded to YouTube. Shem basically said the exact same thing that I just said. Green Yoshi, I'm still learning Godot. I have a little project going, but it's still trying to figure it out. Yeah, Godot is designed to be a like on par feature-wise with all of the big dogs in the industry. So your Unity, your Unreal Engine, those are the two that I always talk about. So it can do a lot of different things, but that does mean it has a slightly higher learning curve. I do think that... Oh, I had something insightful to say. I lost it. It might come back to me. It might not. Excuse me. We will see. Adi Dimmer, I've got one question. That Godot can run smoothly for a low-spec laptop. Yes and no. It is not heavy in the sense that, like, Unreal Engine is a fairly heavy program that I've had it not run on a laptop before. But it is not... I said yesterday when we were talking about this that you should never let the device that you have impact whether or not you will develop something. And I still stand by that, but it might need to change the tools that you use. So if Godot does not run on your laptop, there is, I mentioned this yesterday in passing, but it was the end of the stream and I needed to move on. There is... Oh! Godot has something called the web editor. It's highly experimental, but if you want to mess around with it, I just dropped that link in chat. I know that I'm behind on chat. There's also some people who've said good things about GDevelop. Which has a web app version. I have not used it, but those are some resources for if this doesn't run on your computer, what you can use to do game development instead, because I do not think that that should stop you. Adi, take care of your health. Yep. Green Yoshi, isn't setting up your space just so satisfying? It is. I'm like truly excited to have a lot more space because this room is very small. I can like almost reach out and touch my bed right now. And also it's a lot. Setting up a new space is always a lot. Shem, you're doing a photo background with a green screen. Yes, didn't you say that yesterday? So I said that I wanted to make sure that I took a picture where the camera is sitting right now of this background so that if I ever, like, I don't know, have like a VTuber model or something like that, I can use it as a green screen and as a model so I can preserve it, but I'm not planning on setting up a green screen because green screens are kind of expensive. It's Rays. I love the design of the wall. Thank you. Fatma, it's my first time using Godot, but I tried Unity last year. Yep, that is, I mean, yeah, Godot and Unity are the most similar to each other in terms of their capabilities and their uses. I don't know. They obviously have differences. And Unity has like, I don't want to say more bloat, but it can do more things and people have made more like hacks and things like that for it because it's been around for so much longer. Greyvox, building the game is pretty easy. The issue for me is doing the art. 2D, I mean 3D is another thing. Hey, good for you. Game programmers, game developers are a much needed thing. Hey, Pharaoh, welcome. Shem, now I'm channeling Dimmer. Yep. Okay, I'm almost caught up. Godot has an online compiler, I think. Yep. And then I dropped that in chat. What language are we using for this project? We're going to be using GDScript, which is a, like, it looks kind of similar to Python in the syntax. It is a Godot specific language. You can also use C# and C++ if those are what you're more comfortable with in Godot. I won't be showing that code. but I don't know any language with C in the name. Java, JavaScript, Python, that's where I know. I've never used a C language. So we're using GD script because it's similar to Python. Okay. That is, I think, all of chat. I finally caught up. Going through all of the many tabs that I have opened. Dizzy Lynch, I wonder if I might be. Tactical Fortnite Pyramid, hello. I also love your username. Okay. With that, let's get into it. Okay. That was my chair, and I was like, am I about to fall to the floor? Thankfully not. My chair is still standing. Okay. Let me redistribute my windows, and great. Share a blank screen. I'm going to open up Godot. I already have it installed. This is a good time for you to download and install it if you have not already. It's a very easy install because it is like a self-contained application. I'm just opening up this project because I honestly don't remember. Castle Keeper from Kansas, welcome. Oh my goodness, I forgot that we made this. Tactical Fortnite Pyramid. So what are we doing, hackers? We are going to be building a simple 3D game in Godot and adding a pathfinding AI. Elena, link. Let me get that for you. We're looking at Godot engine. People are making some really cool things in it. Oh, I have so many windows and tabs. I'm using the online editor. Any problem? I have not used the online editor, and it is not designed to be production ready. But for the purposes of this, I think that generally, I think if your computer cannot run Godot or you cannot install Godot, do you download 4.2.1 or 3.5? Download latest. Oh, I should actually update my Godot. I think my Godot is pre 4.0. So I might need to re-download it. 4.1.2. Okay. Which I think is new enough. I don't think there's any features that have been added between 1 and 2. But download the newest version. It's the long-term support one. If you were like a big company that was creating a game that would take years of development, maybe. But for us making some small projects, latest is better. Doc says latest is unstable. So it says that let's does it? Oh, you're talking about, sorry, you are talking about the web version. The web version, yes. The web editor is, yeah, not recommended for production work. But again, it's better than nothing, is how I will phrase it. If you cannot install Godot or cannot open it for any reason, try the web editor and see. I installed, how should it look? So it is a thing that you extract and then run. So I have it in, I just moved it to my applications folder because I'm on Mac. But if you're on Windows or Mac, you can just literally open the file that is going to be godot.exe or godot.app. And then it should look like this, which is our project manager. And then let me grab this, move it over. So this is going to be the tutorial that we're following, and I'm going to put this link in chat again if you want it open yourselves. It's by Bramwell. I went through the first part of this to double check that it's an extremely well done tutorial that goes over all the basics way better than I ever could. I always like showing tutorials like these so that one, if you don't like the pace or the format of I will answer these questions in chat in a sec. If you don't like the pace or format of the stream, you can use the video as a learning resource to still kind of create the same things. Also, so that if we don't finish something on stream, you have a resource to be able to finish the project. Because I know that sometimes projects take longer than you expect, and thus you can't necessarily finish them within the stream. So I want to make sure that I always provide a way for you to have more resources than just the stream. And from what I have seen, the Bramwell's channel is a very good resource for Godot in general. So highly recommend. Should I download Godot Engine or GodotEngine.net? Let's take a look. Download latest. You can just download the Godot engine. The .net, I'm pretty sure is, yes, if we are writing in C#. So if you do want to write in C# in the future, you can download that, but we are going to be writing in GD script. So what do I write in console? You talked a little bit fast. Elena, what operating system are you running? Windows, great. Okay, so you've downloaded. You've gone here. You've downloaded the Godot engine. We're going to unzip that, and then you'll see we have this folder. Go ahead and just open up this Godot stable Win64. And if you go ahead and open that, just double click on it. That should give you everything that you need. Yep, you're looking for stable Win64.exe. The console is a thing that we will use inside of the engine, but it is not what we are going to be interacting with for our main interactions. You're very welcome. This is one reason that I do like doing following tutorials on stream, is because I can go through and answer questions as well. Okay. If anyone else is having difficulty installing, please say something in chat, let me know. If not, then let's go through and watch or start our process of watching this tutorial and following along. I don't remember if it is music or not, so I'm pausing my music. If this tutorial does not have music, which I hope it doesn't, we will continue the music again.
This project is from the ground up for absolute beginners, so we will start by installing my game engine of choice, Godot Engine. Find your way to godotengine.org and click Download Latest, which for me is version 4.1. Then click the blue download button to get a hold of the engine. It works on Windows, Linux, Mac, and more recently on mobile too. Once you have unzipped that download, open Godot and select New Project from the Project Manager window. In the project name text box, I will name the project.
Oh, I also want to quickly talk about this video is set up into chapters, which we can take a look at here. Introduction and setup, creating a 3D scene, creating simple shapes. We will generally watch a full chapter and then we will pause and implement it ourselves and answer questions, then move on to the next chapter. That's generally how I like to follow these tutorials, so that we aren't constantly pausing, so that we can let things flow and kind of make connections and then we implement it. Just wanted to let people know what I'm doing.
Basic 3D platformer. Click Create Folder and then Create and Edit. Now we are in the editor proper, I will take a moment to cover the key areas we will be interacting with. The top bar holds menu buttons on the left, 4 buttons for the main screens in the center, and playback controls on the right. The main screen buttons determine what is in the middle of our display. By default, in 3D mode, this will be our viewport showing us the game world. On the left are two docks, the scene tree showing virtual objects in our game, and the file system for accessing resources like images, sound files, and the like. On the right is another dock containing the inspector. This is where we will configure our game objects. Now we are in the game engine proper, we can get our starting 3D scene set up. We need three things to be able to see our game world in action.
Pausing because we reached the end of a chapter. This is where I will open up Godot. Hopefully you have Godot open as well. And we're going to create a new project that we're going to call 3D Platformer. If I can type. We are going to select forward plus because we are creating a 3D game. Just double checking that that's what they chose as well. I'm like 90% sure.
Edit.
Yes, okay. Forward plus. And then choose a location. Documents. MLH projects. New folder. And it is going to be Global Hack Week. February 24. Select current folder, create and edit. So now we've created a new project. Godot is opening it. Give it a sec to load. Hey, and there we have the interface that we were shown in the tutorial. With that, we've gone through introduction and setup. And let's move on to creating a 3D scene.
Now we are in the game engine proper, we can get our starting 3D scenes.
Oh, and again, ask any questions at any time in the chat. And if it is urgent, I will stop and answer it right away. And if it is not, I will stop at the end of the chapter and we'll talk about it.
Setup. We need three things to be able to see our game world in action: a camera, a world environment, and a light source. Create a new 3D scene by selecting the 3D scene option from the scene tree dock. This node 3D is the root of our scene, and we can add more.
Wait, we just opened it? Elena, yes, we have currently just opened Godot and created a project. And now we are going to be creating our first scene in it. I'm on track now. Great. Okay.
Nodes as children of it. Click the plus icon at the top of the screen to create a new node, or use the shortcut Ctrl and A. Type Camera 3D into the search bar at the top of the Create New Node window, and click on the Camera 3D node from the list below and click the Create button to add this new Camera 3D to our scene. This camera allows us to see the game world when we run the game, but at the moment there is nothing in it to display, so we need to add a world environment and a light. At the top of the viewport, there is a toolbar with buttons for previewing our game world. Select the button with three vertical dots. This opens a menu for adding preview environments to the scene. Click the Add Sun to Scene and Add Environment to Scene buttons to add the default world environment and directional light 3D to the scene. You can customize colors and light angles with the options in this menu. Now we can get our scene running in real time. In the top bar on the far right, you will see 6 buttons that are all playback controls. Click the Run Current Scene button, which looks like a play button on a clipboard. Godot will then prompt you to save the scene if you haven't already. I will name the scene level.scene in the file prompt at the bottom, and click Save. A window will open with our game running, and this will look like the viewport in the Godot editor itself, just showing the procedural sky we added in our world environment as viewed from the perspective of this new camera.
Why don't I have those 6 buttons? Let's take a look. So I see them up here for me. Because again, I'm on Mac OS. They're on Windows, so they were a little bit lower down. Yes, nope, they are the same. I don't know what you mean by that. I'm sorry. If you can give some more details as to what you currently see. There, where do you also have them? Let me go into my settings and let me make my mouse cursor bigger. So that it should be easier to follow. So right up here, there where you also have them, I have them in the same space. So you do have those 6 buttons. Okay. I see what you were responding to now. Yes. Okay. Yep. I understand completely now. I thought, yep, I misunderstood the UI. Thankfully you have them, which is good. Now, what we want to do is we want to create a 3D scene. And then in that 3D scene, we want to add a camera, and we're specifically looking for a camera 3D. And this is what we're going to be viewing our scene through. And then these 3 dots up here on the same as toggle preview environment and toggle preview sunlight, we can add a sun to the scene, excuse me, and add environment to the scene. And now if we click this icon right here, which is to play the current scene, it'll ask us to save it as level. And now, drum roll, please. Hey, we have a scene running. So we can see through our camera what the world would look like. Also, this mouse cursor is just slightly too large. So which button do we click on? Give me 1 sec. From those 6. It is this one right here. So it is out of 1, 2, 3, 4, 5, 6. It is the 5th. Actually, there's 7. But it is the 5th out of them counting from the left. Or Control R, Command R. And when we click that, it runs. Okay, and then save. Yep, it'll ask you to save if you haven't already. I just saved as level, and we can see level.tscn, or that's the file format of a scene. Okay, done. Great. I'm going to start the tutorial again, Elena, but again, feel free to continue to ask questions, and I can always pause.
Now is a good time to add a floor to give us something to look at and get used to orienting objects like the camera. To act as a floor, we need to add a mesh instance 3D to our scene. When you add a node to the scene, it is added as a child of whatever node is selected in the scene tree. Left click on the node 3D to select it. Selected nodes are highlighted with a pale blue rectangle. With the node 3D selected, open the Create New Node dialog. As you might be able to remember, we can either use the plus or we can use the shortcut Control and A. In the search bar, find and select Mesh Instance 3D, then click Create. This Mesh Instance 3D node is our essential tool for showing simple 3D shapes. In the scene tree on the left, you should see the mesh instance is now selected with the light blue highlight. If not, select the Mesh Instance 3D by left-clicking on it. When a node is selected in the scene tree, we can access their properties in the inspector on the right. In the inspector, the Mesh Instance 3D node has a mesh property, where we can select how it should look from a variety of primitive shapes, like box, sphere, and cylinder. To select a mesh for this Mesh Instance 3D, click on the word empty next to the word mesh. Then select New Plane Mesh from this list to create our floor mesh. This plane is then visible in the editor's viewport as a 2 meter by 2 meter grey square. The plane is only visible from above, as a plane mesh is a one-sided object. If you move the mouse over the viewport, you can control the view with a variety of gestures. Click and hold the middle mouse button and drag the mouse up, and your view will rotate down to a view below the floor, showing it is transparent from the other side. Click and hold the middle mouse button.
So I'm pausing because some people on laptops who might not have a middle mouse button. That is where you can use this, I believe it's called a gadget or a widget, one of the two, up here, and you can grab any one of the axes and drag it around with your mouse to move the perspective around. You can also use the middle mouse button, which is probably what I will be doing, but you can also grab things up here. This also acts as a shortcut where you can click on any of these to snap to that perspective. So I clicked on Y, so I'm looking down from Y. If I click on X, I'm looking at the X-axis, Z, the Z-axis, respectively. Just giving some more context, because I know that not everyone has a mouse.
And drag the mouse down to rotate the view back up, and you can see the floor again. The floor is too small at the moment, so we're going to need to update its size in the inspector. The mesh property of the mesh instance 3D now holds a plane mesh object that we can customize. If you click on the picture of a plane, the object will expand and we can customize its properties in the inspector. Godot has objects we can expand like this, as not all meshes will have the same properties. This plane mesh only has a width and a height, but if we say had a box mesh, it would also have a depth property. We can set the floor's size with the mesh's size property. Set the size property's X and Y values to 10 meters by 10 meters. You will see the mesh updates in real time in the viewport.
You lost you here, that's totally fine. I will cover this again and we can go back over it. We have how much longer in this segment? We have another 2.5 minutes in this segment, so I think we're going to finish it out and then go over all of it at once. Don't worry, we'll be back.
While hovering the mouse over the viewport, you can scroll the mouse wheel up and down to zoom the camera in and out for a better view. Now we need to move our camera 3D node for a better view. If we run the scene as it is, we will not be able to see anything because the camera is inside the floor. If you ever quickly want to check what the camera 3D can see, select the camera in the scene tree and hit Ctrl P to toggle the camera preview. This will show what the camera can see directly in the viewport. You can also toggle this view with the preview check mark in the top left of the viewport. To update the camera's position and orientation, we can use the 3D gizmo. This is a handy tool available directly in the viewport for whatever node we have selected in the scene tree. Select the camera 3D node in the scene tree so we can update it with the gizmo. The gizmo is the 3 arrows and circular arcs in green, blue and red in the viewport. The gizmo is centered on our camera, which is made visible as a small purple pyramid with a square base indicating the direction the camera is pointing. If you hover your mouse over the tips of the arrow on the gizmo, the arrow will change to white. This indicates you can drag the whole node in that direction by clicking the left mouse button and dragging. The motion is locked in the axis of the arrow. Click the green arrow and drag the camera upwards. If anything happens you don't expect, the editor supports using Ctrl-Z and Ctrl-Shift-Z to undo and redo actions. We can now use that preview toggle to see what the camera can see from its current position. The grey floor should be visible at the bottom of the screen. This gizmo updates the position and rotation property that all 3D nodes have. We can update those values manually in the inspector. Find the Node 3D section and expand the Transform dropdown. You should see the position's Y property is something other than 0 as you changed its position with the gizmo. I will manually set the camera's height to 2 meters up by selecting the Y value in the position property and entering 2. Now when running the current scene with F6 or the play current scene button, you should see the same thing I do here.
Great, okay. So that is our next chapter, which is called Creating Simple Shapes. So let's go through. We have a scene, we have sun, we have an environment, we have a camera, but we don't have anything in it. And Elena said that they used the mouse to watch the figure, just lost me in the last inspector. Great. So our first step here is we're going to click on our node 3D, and then we are going to add a child node to it. So we're going to click that button, and it's going to be a mesh instance 3D. This is again how we add 3-dimensional objects to our 3D game. Now with mesh instance 3D selected, we now click on empty. And the goal here of clicking on empty is we're saying this can hold a mesh, and a mesh being a collection of points that makes a shape in 3 dimensions. But we currently don't have anything inside of it. So when we click on that, we get a drop down. Alonzo, I will answer that in a second. We get a drop down of all of the different types of primitive shapes that we can create. So a box is a great example of a cube, prism, sphere, that sort of thing. Now what we also have is a plane being a 2-dimensional series of points. And if we click on that, hey, we've created our plane. And this is where we can use, again, these camera controls to look around. If we look under, we see there's nothing there, but if we look from above, we see that something's there, because again, a plane is a one-sided thing. So it is a 2D object in a 3D space. Now, if we click on Mesh Instance 3D again, because I moved the camera and I deselected it, this is the part, Elena, I think you got lost. We click on this drop-down arrow here now. Sorry, the image of the plane, to get all of the information about this object to be able to edit it. If we were using something more complicated, let's say we had a character that we had modeled in something like Blender or ZBrush, this is where we would be able to theoretically, emphasis on the theoretically, change the attributes of that character. You might need to actually do that in the original program, but here, because we are doing it all within the, inside of Godot, we have these options right here. And in this case, we wanted to make the floor bigger. So after you click the arrow, new plane mesh, after you've created it, you click on the image, and we're going to increase the size because it's currently 2 meters by 2 meters, and let's change it to 10 by 10. So now we have a bigger floor for when we create a character for our character to stand around on and move and all of that. So now we have our floor. Now what we want to do is move our camera up because our camera is currently inside of the floor. So Elena, if you still have questions, feel free to ask. I'm just moving on because I know that there's a lag between me saying something and chat. So what we can do is we can either click on camera in here, or we can click on the camera 3D node in our scene tree. And once we do that, we get this gizmo right here, which gives us the ability to rotate something, to move it along each axis. And then I believe, yeah, these are just like normal grab handles where you can move it along multiple axes at once. So, okay, there we go. So we have a bunch of different controls. In this case, we just want to move the camera up so it's not inside the ground. So we can click on this up facing arrow that is along the Z axis, and we can click and drag to move it up. And you'll notice, hey, we've moved it up. But in this case, we want to move it up specifically 2 meters tall. And in order to be more precise with that, in our camera 3D inspector, so we have our scene tree where we have a list of everything that is inside of our scene. And when we click on a node, we get more information about it and its different properties inside the inspector, where here we can open up transform, and we can change our Y value to 2, and we can see that it moves up to 2 meters off the ground. And now to double check that we're at the same point in the tutorial, we can click preview, and you will see roughly the same thing as
See the same thing I do here.
is in the tutorial. In this case, I believe that that is a slightly larger screen. Oh, that is an old project. Let me quit Visual Studio Code. Okay. If I fully run the game again, we should see the exact same thing. Yes, we do. So we know that we are following. We have a camera, we have a floor, we know how to move things around, we know how to adjust the properties of a mesh, like in this case, this plane. I'm going to give it another couple secs, so if people have questions. And while I'm giving that time, Alonzo, hello, welcome, it's nice to see you again. We are making a 3D game in Godot game engine. Elena, if you have questions, feel free to just type them out. So I don't remember if you were here for one of my previous Godot streams. But in our previous streams, we've created 2D games in Godot, an open source game engine. And in this instance, we are switching from this 2D tab where we've always worked before over to this 3D tab and creating a 3D game. And then not tomorrow, on the 14th, my next stream, we're going to be adding an enemy that does pathfinding to follow the player. Can we call that an object? So in this, we generally don't call things objects because object is a very broad term. We call these right here nodes, over here, and then we would call, in this instance, this plane, we would call it a mesh because it is a collection of points in 3D space. So I guess they could be called objects, and from like an object-oriented programming perspective, they're probably objects because they each have their own like properties. I'm blanking on the term for that in object-oriented programming. Oh golly. If you understand object-oriented programming, you get my point. If like each of these has its own private and public properties, and then also we can have scripts connected to each one of them that has private and public functions. So they are objects in that sense. But in this case, we're going to refer to these as nodes inside of a node tree and things in our 3D space as a mesh. Not Godot, just for last Q&A. Okay, I tried Godot long ago, but it's too much for my 2017 Mac. Is there a lighter version or a way to make it less demanding? Good question. So we were actually talking about this earlier. This is a new thing in Godot where they have, you go to the download page, you can scroll down and you can see there is a web editor, which I will drop the link in chat for. And it is not entirely stable, and it is not recommended if you are trying to like create a game for publishing, but it is plenty good for learning on. I'm kind of late. Anyone here available to go over this later on? So I will not be available later on, but the good news is that we are following a tutorial here. So Shem making very good points here. And also the link that I just dropped, that YouTube link, is the tutorial that we are following. And also this will be up on the MLH YouTube channel under the live tab, so you can always watch the recording. Is there an attendance link? Yes, there is. It's in the Discord announcement, but I will also drop it in chat if I can find my notes. That's the right link. Yes, okay. There you go. There's the check-in link. Gonna give it another little bit for people to ask any more questions that they have. Thank you, Shem. Hey, Jackson. Nice seeing you again. I don't know if I saw you earlier in chat today. I don't think that I did. Okay. With that, let us continue on our journey of learning.
Godot offers many powerful graphical options to control the appearance of what you create, and it is best to understand these settings early so you can fix graphical problems as you encounter them. In the top bar on the left, select the Project drop-down, and from that drop-down list, click on Project Settings. The Project Settings window holds a host of powerful options for your games, as well as a bunch of useful customizations. In the tree on the left, you will see a variety of tabs for options relating to your project. Under the Display drop-down, click on the Window button, and options relating to your game window will open on the right side of the page. I am using a 1920 by 1080 monitor, so to best fit, I'm going to set my viewport width and heights to the same dimensions. I also want my game to take up the full screen and leave the mouse free to close the window, so I'm going to change the mode to maximized. The stretch mode and resizable options on the screen are often important in letting you make the screen have fixed dimensions and stretching pixels to keep the viewport scale the same on different monitors. The next important setting to cover is anti-aliasing options. Under the rendering subheading, you can find and select the anti-aliasing tab. Anti-aliasing options help us avoid jagged, sharp contrast edges in our games. These options are all disabled by default for the best performance. Hovering over the names of options like MSA 3D will reveal a tooltip giving you more detail about the option. I'm going to set the multi-sample anti-aliasing MSAA 3D to 2 times. To keep this window streamlined, Godot 4 added an advanced settings toggle in the top right. Clicking on this toggle will reveal many more project settings that are worth scrolling through and investigating at your own leisure. Click on the toggle and scroll down to Lights and Shadows, under the Rendering drop-down. Here we can control the quality of our shadows. For the moment, we only care about the directional shadow section, as that covers the sun we added earlier, and we don't have any other lights. Click on the drop-down for soft shadow filter quality, and you will see a whole host of options. I will slightly improve the quality by changing the quality to soft medium. We are now...
Okay, so that is going over graphical settings. Shem, I will respond to that because I feel that very strongly in a sec. Under Godot, project settings, we'll notice that we have a whole bunch of different settings for our project. In this case, we went through specific graphic settings, which I agree are good to know. In this case, window, they made it 1920 by 1080, and they switched it to mode full screen. I'm going to switch it to 1280 by 720, so that it doesn't take up my full screen, and keep it windowed because I'm streaming and I don't want to keep switching back and forth between full screen and not. But this is where you change what the resolution of your game is going to be, along with whether or not you want it to be windowed. Maximized is going to be like taking up the, let me show an example here. This is a windowed window. This is a maximized window. And this is a full screen window. You'll notice the difference here between full screen and maximized. You don't see much because my taskbar is to the left where chat is in above me. And I don't show that to you because there's nothing useful there. And you don't need to see like all of the different tools that I've opened along the side. We have the Finder, we have Chrome, we have Firefox, we have OBS, we have Elgato, Wavelink, we have Discord, we have my antivirus software, which I don't know why it's open right now, and we have Godot. So I hide that from y'all. But we can see that there's a big difference when I go maximized because we also lose that top bar in macOS. So those are our different options there. In Windows, it's even more like impactful because the top bar of an application is inside the application. Those are fairly standard different settings of how a different games render. So I'm just going to leave it 1280 720 windowed. And then we talked about anti-aliasing, which was under rendering, anti-aliasing. I'm going to keep it disabled because we are talking about running this on basically everyone's different computers. And some people have already mentioned that their computers aren't super powerful. So we're going to leave that all off so it runs the best. And then they also talked about under advanced settings. No, it was under shadows. Render. I am. I'm going to need to refer back. I'm usually pretty good at remembering advanced settings on.
Yeah.
Rendering and okay.
Click on the toggle and scroll down to Lights and Shadows.
Okay, it just was hidden. Click on the toggle, scroll down under rendering to Lights and Shadows, and then they turned up their directional shadow from slow low or soft low to soft medium. I'm again going to keep it on soft low so that this runs faster on different computers. These are all different ways of basically telling the computer do more processing to make it look better, but in this case we don't want it to do that more processing. So that's what those settings were. Howdy, how's the project been going? It's been going very well, thank you. We've been learning a lot about 3D in Godot. And then Shem, I kind of a lot feel like since I don't play these kinds of games, it would be super hard to come up with them / code them, even with a tutorial. And I feel that so much. There's a reason why I am not like a game developer. And I really don't play games that much. I think game design is fascinating. I think all of the technology behind this is fascinating. And I also just like don't have ideas for a game. And that's fine. I enjoy messing around with this. I enjoy learning about it. And if someone were to come up to me with an idea, or there was at one point where I did a game jam, where I was able to come up with an idea, but it's not a thing that comes naturally to me. And I think that is totally fine. A lot of people in the computer science community are gamers, but also some of us are not. With that, those are those settings. None of that is essential, but again, it is very good to know, especially when you're clicking this button and you're going like, oh, why doesn't this look the way that I want it to look? Because Godot can create very pretty games. That is not... Unreal Engine is the best in the industry right now at creating like hyper realism, but Godot can create, again, very, very pretty games. With that, unless anyone has any questions, we are going to move on to supplemental material. It's short enough that we're going to watch it. I've gotten a from Elena. I'm going to hit play. Oh. How did you say? Oh, so, okay. This thing up here where we can move around our scene and look around, I believe it is a gizmo. Let me double check. So at least it is called a viewport gizmo in Blender. Yeah, these are gizmos. So yeah, this is a gizmo. And if we were to click on our camera, that is also a gizmo. Of course. Okay. Let's watch some supplemental material, which probably is going to be some of their other tutorials. We'll see.
We are now 1/3 of the way through my guide on how to create a 3D platformer in Godot 4.1. This is all part of the free supplement in my course Godot for Beginners. If you head on over to itch, there's a link down there, you will be able to go ahead and download these 3 sections all in written form so that you can follow along with that if you find that a more helpful way of learning. Once that's all wrapped up, there are 7 more sections available covering a bunch of extra topics relevant to 3D platformers, such as transitioning between levels, making grid maps, particles, and the like, all available in my course Godot for Beginners, and I'm considering creating more video content like this to go ahead and cover those topics in the future. Anyway, I'll let you get back to the rest of the video. Okay, have fun.
So yeah, I am never going to tell you that you need to buy something in order to learn. I think that there's plenty of information, especially in computer science, out there, but I always want to make sure they have a great voice for this sort of type of online content. He does. I believe he, him pronouns. I want to make sure. I think yes. Okay, he, him. He does. A wonderful voice, wonderful pacing, very good at describing things. There's a reason I chose this video. But yeah, I always want to make sure that that sort of thing is advertised because these creators and teachers are doing wonderful work. But I am not endorsing nor saying that you should or need to buy that course. But I do like this tutorial, and I do think that poking around this person's YouTube channel can be a good thing if you want to learn more about Godot.
Now we have a simple level, we can focus on getting our player character up and running. We may want to add the player to a variety of levels like this one, so we will make the player its own scene. In the top bar on the left, click the Scene drop-down and select New Scene. In the new window in the scene tree, select the Other Node option. When you select the Other Node option, the Create New Node dialog opens and lets us select any node to be the root of our scene. For our player character, 2 nodes are up for consideration: Rigid Body 3D and Character Body 3D. I am going to show you how to make a Rigid Body 3D player character. This is physics-based at the cost of less precise control than the kinematic counterpart. In the search bar, find Rigid Body 3D, select it, and click Create. Now we can see our Rigid Body 3D in the scene tree. double-click on the node and rename it to player, then hit enter. When you create a body node in Godot, to make them interact with other nodes and the physics of the engine, we need two things: a mesh so we can see the body, and a collision shape 3D. Add a mesh instance 3D as a child of the rigid body 3D we named player. This node is how we will see our player. With the mesh instance 3D selected in the scene tree, look to the inspector on the right. Click the mesh property dropdown and select new capsule mesh from the list. When you have a mesh instance 3D, you often will want to create a matching collision shape. To help with this, there is a contextual mesh dropdown at the top of the viewport we can use to generate a collision shape 3D. With the mesh instance 3D selected, click the mesh button at the top middle of the viewport. Then, from the drop-down, select Create Simplified Convex Collision Sibling. Now we have our collision shape, we can focus on setting up our rigid body 3D for use as a player character. Select the rigid body 3D player in the scene tree, and in the inspector, find the lock rotation property and enable it. Rigid bodies are often used as physics objects, with great freedom of movement and rotation. We need to lock our player's rotation so the capsule does not tip over as our player walks around. Godot uses script files to give instructions to the objects in our...
Okay, so that is the chapter on creating a player character. So we're going to open back up Godot and we're going to implement this. So they mentioned that the first thing that they did was Godot new scene, and they mentioned it was so that our player character could be at multiple places. I will talk about lock rotation. I will get there. At once. And the reason why is because scenes in Godot are not necessarily scenes in the way of like a movie scene or a book scene, but rather they are objects, is a good way of referring to them, where they contain scripts and meshes and lighting and cameras and all of these different things, this entire node tree. And also, it is an object, or it is a tool that we can instantiate in our game. So if you have, let's say we're creating a Mario Brothers game, we would create a scene that is called a Goomba, and we can make multiple Goombas in our main level by creating multiple Goomba scenes, quote unquote. So that is why we are creating a new scene. Hopefully that makes a little bit of sense. And our root node here is not going to be a 2D or 3D scene. It is going to be other. And it is going to be a rigid body 3D. And the reason why we are using a rigid body 3D is because a rigid body is a type of object in physics simulation. So there's soft and rigid bodies. If you think about like a gelatin or a bouncy ball or a rubber band, that is a soft body. It flexes when things interact with it. But if you think about like a bowling ball or a block of wood, that is a rigid body. It does not flex when things interact with it. It can get knocked off rather than squishing. So I have this yarn here. This is a soft body. I can squish it. I have this empty can of seltzer right here, and it cannot be squished. It is a rigid body, and I'm squeezing it in this direction because I could theoretically crush it. But that's rigid and soft body. In this case, we're using a rigid body because we want to be able to simulate the physics of the character. Now, there is also an option that he mentioned that was for a player body 3D, I believe. Character body? Character body 3D, which uses a different system for calculating those physics, which is more tweakable, but slightly like you can make things that feel weird with it more easily because it's not directly replicating the physics. It is giving you leeway to kind of invent your own things. So a lot of platforms have faster gravity so that things feel faster and the person just jumps really hard, that sort of thing. So we create our rigid body, and then we're going to add a child node. We're going to add a mesh 3D, a mesh instance 3D, and then we're going to do what we did before, where we are going to create this time a capsule mesh. And then we need to create a collision object. And the distinction here, it wasn't talked about yet, it probably will be later, is our meshes are a series of points. And when we create a mesh instance, the point of that is that that is what the camera sees, that is what the player sees. but there's nothing actually coded into this. So we could have if we were to create this and we were to add this player to our main scene, it would fall straight through the floor because the game doesn't know how to calculate if things are touching. So to be able to see if things are touching in 3D space, what we do is we add in this case, it is create simplified convex collision sibling, but we could add this separately and manually. This is just the automated way of doing it. We create a collision shape. And the point of that collision shape is that this is what will actually interact with the world, so something can bump into this and hit it. Now, the thing that y'all got confused on was lock rotation, and understandably so, because it is very weird. The reason why is we are using a capsule here. So we'll notice it's a cylinder with a semi-spherical, hemispherical, either way, top and bottom. And the reason why is so that if we have, like, let's say we have a slope and we have the floor, and we want our character to walk up this slope. This curve allows us to do those. Physics calculations much more easily than if we had something like a cube where there's a hard edge that can get stuck. So that is why we're using a capsule. Whereas lock rotation, I will answer that. We use a capsule for that reason. The collision shape was generated right here underneath our mesh instance inside of our rigid body. So again, this is a tree. So we have rigid body, and then inside of it in the tree structure, we have mesh instance and collision shape. So collision shape was created inside rigid body under our mesh instance. And when we click on rigid body 3D, which is our entire character, including the mesh and the collision, we have this lock rotation option right here, which we are going to turn on. And the reason why is this does not stop our character from turning or from rotating, but it stops when it's doing physics calculations from those physics influencing it. And what he showed, was a very good example of why that matters. If I can find it. So right here, we have our player, we have our floor, and when we start the game, it starts simulating gravity, and our player falls.
We need to lock our player's rotation so the
down to the floor, and then it immediately falls over because it is semi-spherical on the base. And we do not want the player to wibble and wobble and fall down. What we want to do is we want it to be able to stand straight up. So if you do not see lock rotation, let me see if it is. If I delete that node. Interesting. So it is not that. Let me recreate that node before I forget. If one of you can tell me what you do see in the inspector panel when you click on rigid body 3D. Wait, I think I see it under deactivation. So if I have nothing selected, I click on rigid body 3D, which is our parent in this case. And then we select lock rotation in our inspector. And it doesn't require you to scroll. It should be open by default, theoretically. But I might be missing something here. I'm waiting for hopefully some more context from oh, it's not, it's Reyes, it's Reyes. Sorry about that. It's Reyes. Wow, I really cannot read. Reyes. Woo. I am slightly dyslexic if you cannot tell. And then we have Elena. We're both talking about not being able to see lock rotation. If you can give a little bit more context as what you see, or if you're in the Discord, you can drop a screenshot in, let me see what an appropriate, oh, I can see it now. Great. Okay. As long as you can see it now. Theoretically, we could, you did, problem solved. Great. Okay. Then let us continue, because now we are talking about writing a movement script. So currently we have a player, but it can't move anywhere. It can't do anything. We cannot control it. So let's move on to that. Reyes, lol, you're good, and I see it as well. Thank you. And I'm glad you see it as well.
Godot uses script files to give instructions to the objects in our games. We write these in the GD script language, a specialized lightweight scripting language. We will add a script to our player character that will listen to key presses and use those to move the player in the corresponding direction. Right-click on the rigid body 3D root of our scene, and from the drop-down menu, select the Attach Script option, which is an icon of a little scroll of paper and a green plus. This will open a contextual window for creating a script file. We do not need to customize any of these options, so just click Create. This will change our main screen for the first time. Instead of seeing the 3D viewport as usual, we can now see the script screen. You can swap back and forth between these screens by clicking on the 3D button or the script button in the middle of the top bar as you need them. Our script has a few lines that are important to us right now. The first lines of the script says extend, then the name of the node, in our case, extends rigid body 3D. This tells us the script is attached to a rigid body 3D node, and we can access all the properties and functions of a rigid body 3D in code. Two functions have been added to this script by default. The functions are defined with the keyword func, followed by their names and parentheses. We will be focusing on the process virtual function. Godot has a bunch of virtual functions. A virtual function is a kind of built-in function you can add for a specific task. They have a specific name and specific parameters. Process is a virtual function. It runs every frame, so usually 60 times per second. This makes it an effective way to update your game in real time. The delta parameter tells us how many seconds it has been since the last frame, which is necessary for making changes appear the same on different machines, no matter how fast the game is running. Functions use indentation to separate code into blocks, so the pass keyword is indented to show it is inside the process function. The pass keyword indicates we do not want to do anything in this function. You are not allowed to leave a function empty, so pass is often used as a placeholder.
Again, this is like modified Python syntax, so it is not exactly the same, but if you do have Python experience, this should look familiar. If you don't, I will do my best to answer the questions, but we are not going to be directly focusing on GD script or Python. We're focusing more on the game engine itself.
In the process
Again, you can use C++ or C# with Godot engine as well, if those are languages that you know better.
function, we can listen to input from the user, and if the forward button is pressed, move the player character forwards. Input is a global script you can access from anywhere. UI up is an event for the up arrow key. If this up button is pressed, the getActionStrength function gives us a value of 1.0. Otherwise, it returns 0.0 and the player will not move. So now I'm
going to add more onto here. Sorry for I keep pausing, but I want to make sure I add context. Input and UI up. UI up is not directly mapped to the up arrow key. What input allows us to do is to write code one time that works across many different input methods. So we say when we get a type of input that in this case we've named UI up, in our project settings we determine what makes the game go, oh, UI up has been pressed, which can be, if we're using a controller, it can be a joystick direction, which is why it's returning in a float number. So it's returning 1 or 0 because we're using a keyboard in this case. But if you're using a controller, that can return 0.5 if the stick is only slightly pointed forward. Or you can enable both arrow keys and WSD to control your character. Or you can do a whole bunch of other things. And this allows us to abstract that outside of our code itself so that if and when you change how input is happening to your game, you do not need to change all of the different times where you check to see if the user is pressing a button. You can just change what each button means.
variable input is either 1.0 if the up arrow is pressed, or 0.0 if it isn't. Apply central force is a function of the rigid body 3D itself. it lets us apply a force in a 3D direction. 3D directions are represented by the vector3 object, and vector3.forward gives us a vector3 pointing forwards. The asterisk symbol means we are multiplying the velocity by the 1200.0 that comes after. This makes the force we apply larger, so the player will move further forwards when the button is pressed. We need to multiply the force by delta to avoid issues on machines with different frame rates. When the button is not pressed, multiplying the direction by 0.0 will give us no velocity. This force applies every frame, and combined with the mass of our rigid body 3D, gives us a forward velocity when the up arrow is held. To test...
Okay, I'm going to pause here because this is a long section. Sorry, my camera went black. I just got cold and needed to put on a sweatshirt. So, what we've done is we've added a script, we've gotten input, and now we are trying to move the character around. So let's implement this and then we'll test it afterward. So if we open up Godot again, we can right click on our rigid body 3D and attach a script, which is how we add code. Oh wait. Oh goodness. Okay, I forgot to rename this. We want to rename this to player. Great. So now when we create a script, hey, we create a script that's default called player, and we can just create it based on the defaults, and we get the code scene that we were talking about, code screen that we were talking about before. So again, we see that this extends rigid body 3D, which is a class, again, object-oriented programming, if you know that. And then we have the function ready, which is called when the node enters a scene tree for a first time. And then we have function process delta, called every frame. Delta is the elapsed time since the previous frame. So this allows us to do something every frame of the game, where games are running anywhere between maybe 10 frames a second if your computer is struggling, to up to 100 something if your computer is doing really well. And the reason why delta is here, and we'll talk about this in a sec, is to enable us to have our physics calculations not based on how fast your computer is, which we'll talk about. So what we did here, if I can, excuse me, Godot, why are you not letting me move this window around? Okay, there we go. If we take a look here, actually, I'm just going to move this to my second monitor while we talk about it. We're working with our process delta function right now. And what we are adding is we are adding a new variable, var input. This is where it takes a little bit from JavaScript. And we're going to, where input is equal to input.get action strength. And then we are looking for UI up. Oh my goodness, quotes. UI up. So what this is doing is we are creating a new variable that we are calling input, and we are setting it to using the input tool, for lack of a better word, object. It's an object, I think. Class. Anyway, we are running the function get action strength, which again gives us the value of, if this were a joystick, a decimal value of forward, backward, left, right, whatever we're looking at, or in this case, because we're using a keyboard, a 1 or a 0, depending on if UI up is pressed. And to show you, let's go into our project settings, and if we turn off advanced settings, and we take a look at the input map tag, and we click show built-in actions, we can see, you do not need to be following along, this is just to illustrate, UI up here, we have, it is set to the up key on our keyboard, it is set to joypad button 11, D-pad up, or joypad axis 1, left stick up. So we already have it built in. So if I were to connect a game controller to my computer and I were to move the left stick up just a little bit, it would show as UI up with a decimal value. So that is the value of using this rather than specifically looking for a controller or a keyboard press. So that is how we check, should the player be moving forward, is that control being added? And then we are going to apply central force, because this is a physics object. So we are going to push it in a direction, and it is going to be input times vector 3, which I will explain, dot forward times 1200 times delta. So if can I get any more space for this to not be great? Okay. Actually, they hid the inspector. There we go. That's what we're looking for. So Lottie and Elena, I will answer that in a sec. What we are doing is we are applying a force times inputs. This is the value if a keyboard is pressed 1 or 0, or if it's an analog input, the amount. So we are taking the amount that the player is supposed to move forward. We are multiplying it by the vector 3 forward. For those of you who have taken a physics class, you know that a vector is just a value with a direction. There's an iconic clip. I think this is what we're looking for.
Hey. Vector. A quantity represented. It's
Okay.
a mathematical term. A quantity represented by an arrow with both direction and magnitude.
Sorry, I kind of butchered that in trying to find the right place, but a vector, a mathematical concept, an arrow represented by both quantity and magnitude. Direction and magnitude. Golly. In essence, it is we want to go forward, and it is asking forward by how much. So that is a vector. That's a very bad explanation of a vector. I apologize. We're multiplying it by 1200. That is like the amount that we want to be moving forward, and we're multiplying so that if input is 0, we're moving forward nothing. And then we multiply by delta, delta being the amount of time that has elapsed since the last frame. So if our game is running at 120 frames per second, we are not moving 10 times faster than if we were only running 12 frames a second. So we will move the same amount no matter how many frames. In essence, if it takes longer between frames, we will move further between those frames. That's what this code does. From the video, input that checks whether there's an input, and get action strength checks whether it is up or down. Yes, that works. Yes. Up or down in this case is because it is a keyboard. Again, because this can be more than a keyboard, it is the amount that it is pressed. So in this case with a keyboard, it can either be on or off. But if it is like an analog trigger on a joystick as well, then that is like a number that can be between 1 and 0. What's velocity? Velocity, like Pharaoh said, is displacement over time. It is another physics term. You use a lot of physics in game development, especially in 3D game development, where we are trying to simulate something where the velocity is how fast something is going. It is, in essence, speed. But there's a difference there that before someone corrects me in chat, speed is a number, whereas velocity is a vector. So I can be going 50 miles an hour speed, but me telling you that doesn't tell you which direction that I'm moving. But if I were to tell you that I'm going 50 miles an hour north, that is a vector. Again, if you have not taken a physics class, I apologize. I'm not the best explainer of this sort of thing. I can explain the code, I can explain what the engine is doing, but that's not the best. By what units are the 1200 being measured? Really, there isn't really one. That is not like going to be a meters per second or something like that. I'm sure that you could do that math if you wanted to work that out backwards, but it is just a random number at this point, because input being a value between 0 and 1 is manipulating things, and delta is also manipulating things. This 1200 isn't like directly connected to anything. I guess delta is our delta t if this is a physics equation. So I'm sure that you could figure out what this meant in units, and maybe there are units. Let me double check this before I go on too long. Yeah, to my knowledge, yep, this is just based on like random engine units. Also, if vectors are confusing, let me drop the link to this page right here, which is the documentation where they explain how vectors work in Godot and in game development. Hopefully that at least started to answer some of your questions. I know that that probably did not answer all of them. With that, I'm going to go back to our video and keep going.
This script, we need to save the scene. In the top bar, click the Scene dropdown and select Save Scene. The Save Scene As prompt should automatically name the file what our root node is called, player.scene. Click Save. This player is now a scene we can see down in the scene tree. Double-click on level.scene in the scene tree to reopen that scene. Then, in the top bar, click the 3D main screen button to return our view to 3D. Now we can add the player scene to the level. Click on the root of the level scene in the scene tree to select it. Right-click on player.scene down in the file system and select Instantiate from the drop-down menu. Instantiating a scene creates a copy of that scene as a child of the currently selected node. Now the player will be visible in the level, but there are a few things we need to clean up before we can start running the scene. First, our player is clipping through the floor in the middle of the viewport. This makes sense as the player's center is in the middle of their mesh instance 3D, so we need to raise the player up. Select the player node, and in the inspector, find the transform section and expand it. Set the position's Y value to 2 to raise the player above the floor and the Z value to -2, so the player is in front of the camera. If we run the scene now, our player will fall straight through the floor. This is because our floor is just a mesh and not a physics body like the player. In the level scene, select the floor mesh instance 3D, then at the top of the viewport, click the Mesh Context button and select Create Trimesh Static Body from the drop-down menu. This creates a static body 3D as a child of the mesh instance 3D, with a collision shape matching the mesh itself. A static body 3D is another kind of physics body Godot uses that is intended for objects that do not move. Now, if we run the scene with the Play Current Scene button in the top bar, when the game runs, the player will fall to the floor and stay there. If we push the up arrow on the keyboard, the player should then hurl themselves off of the platform.
Okay. So let's now finish creating our player character. So we are going to save, so scene, save scene, and we're going to call it player.scene. And now we switch back to our level. We have our player here. We're going to look at our layer scene, level scene, and here we have our script editor. We're going to switch over to our 3D editor. And then we are going to select node 3D. Wait, I could have sworn. How do I instantiate it? I totally thought I knew that.
Create a copy of that system and select Instantiate from in the scene tree to select it. Right-click on player.scene down in the file system and select Instant.
Ah, thank you. GD being the Godot script itself. If I go to the scene and instantiate, ta-da! Thank you so much, player. Or Pharaoh. Goodness. Shrey found a resource. I'm not going to look at that right now, but Pharaoh, if that is useful to you, I hope it is, because that is something that I don't necessarily understand super well. Now, what we're going to do is we want the player to be above the floor rather than inside of it. So we're going to go into our player. We're going to scroll down to transform. And we are going to move the position up by 2 and forward by 2. So they... So our camera is facing the opposite direction of our tutorial. So we're going to set that to -2 in order to go in front of our camera here. And now if we run the scene like they talked about, we should fall through. Yep, there we go. We can see that our player is in front of the camera though. And now what we just want to do is we want to make our floor a physics object that we can interact with and collide with. So we're going to click on mesh, create tri-mesh static body. And again, a static body being something that cannot be pushed, basically. Our player, if we were to have a cannonball in this game and that cannonball were to hit the player, we want the player to move. But if the player hits the level floor, we don't want the floor to fall out from under them. So we create it as a static body. Now, if we again run the scene, hey, we have our player, which then stops when they hit the floor. And if I hold down the forward arrow, it goes forward. And if we keep going forward, it can fall way down. Elena, you have a question, I assume, by the weight? What did you do after the transform? Okay. So I went down, I transformed it, and now what I want to do is I want to make our floor something that we can collide with. In the same way that in our player, we added our collision shape 3D, we're going to add a static body 3D to our floor. So we're going to click on it. Subhankar is, I think, the way that I pronounce that. Subhankar Ray. Wait, same question. Click on Mesh Instance 3D. Click on Mesh. Click Create Tri-Mesh Static Body. So again, we're taking our mesh, which is what our camera sees, and we are creating a physics object. In this case, a Create Static Body 3D out of it. Is that vector 3 direction? Jackson, I don't know what you're referring to. If you're talking about the transform right down here, yes, that is 3-dimensional. We have X, Y, and Z. If you are talking about in our player script, you'll notice that we used a vector 3 to show a 3-dimensional vector rather than a vector 2, which is a 2-dimensional vector. Those are the only two things I could think of. Lottie, I can't seem to get my player to move. Okay, well, let me double check. Great, okay, I have movement. So there are really two things here. If your player is in this scene, but is not moving, what you want to do is you'll want to see if this scroll is next to the player, because that scroll means that it has a script associated with it. If not, we want to go back to our player here and click on our player and click this. This will be a plus button in front of that, because you might have accidentally added the scroll to either Mesh Instance 3D or Collision Shape 3D, probably based on the sounds of what you're talking about, Collision Shape 2D or 3D. So our invisible collision shape will move forward, but this mesh will not. I actually don't know if that would cause the behavior that I'm talking about. But check to see if your script is in the right location. If it is, respond back, and we can troubleshoot some other steps. We can look at your, I'm going to pull up the script itself so you can make sure that your code looks the same. NAJaxon, if you can specify that vector for me. It is in the right location. Okay, if you can look at it and see if its code matches this. And you were using the up arrow key on your keyboard, correct? Also, I think you pushed the up key and then the object moved in the 3 vector. Ah, yes, it moved in the direction of this vector. Yes, because we specified it as forward. Yes, I am. Just checked the script matches it. Okay. Then I guess the next question is, when you look at your level scene, is the player in front of the camera? I assume it is, because you talked about not being able to get the player to move forward. And does the player stay on top of the ground? If those 2 things are true, then there's only one thing left, which is when you hit play, make sure you click on your like game here to make sure that it's selected. Does that mean -3 vector would move back at you? Yes. So if we're probably going to do that with moving the player backward. But what we can do is finally it works. Hey, I'm glad that that's working for you. What we will do is we will specify vector 3. I'm just going to switch it to backward. Is it just back? Forward. Okay, it is just back. And now if I save this and we run the scene, now if I hit the up arrow, you can see that we go towards the camera, because yes, we're using dot backward, which is the exact same as -forward. It is just easier to use the names there for these sort of simple vectors because it makes the code more readable. Nice, thanks. Yeah, of course. Lottie, hopefully it is working for you. If it is still not, what I will ask you to do is to send a screenshot in the Discord. Oh, I'm slouching. Oh, sorry. Didn't mean to ram the microphone. Oh. It's still not working, but I'll keep working on it. Okay. Yeah, I can't think of what would still be causing that issue. If you want, you can take screenshots of what your Godot looks like and post them in what would be the right channel here. It would be in... Global Hack Week, AI ML Week, that channel in the Discord. If you want to take a screenshot and post it in there, I can look at it before the stream ends. But other than that, we are going to keep moving forward. Oh, and if you aren't in the Discord, discord.mlh.io is the place to go to join. Let us continue with our tutorial.
Most modern games do not use arrow keys for movement, instead opting for the W, A, S, and D keys. To set this up, we need to configure input events for the project. Godot lets you access every input the user makes, but for convenience, multiple input device support, and to easier group events, you can use the input map, which lets you mark a specific event with a name. You can even make multiple inputs trigger the same event. For example, both the spacebar and A button on controllers triggering a jump. In the top bar, click the Project drop-down and select Project Settings. Then at the top of the Project Settings window, click the Input Map tab. The UI up event we listen to for movement is defined here, but is hidden by default. Click the Show Built-in Actions toggle to see all the predefined actions you can listen to. In the Add New Action bar at the top, type move_forward and hit Enter, or click the Add button. This creates an input event called Move Forward that we can attach inputs to. On the right of the Move Forward input event, click the plus button to open the event configuration window. In this window, you can either select the input you want from the drop-down menus or push the actual input for the event you want. If you push the W key, the panel will update to show the W key, and that it detected a physical key press. Click OK to confirm this is the input you want, and now whenever the W key is pressed in-game, the Move Forward event will trigger, which we can look up by name. Repeat the process for Move Left with the A key, Move Right with the D key, and Move Back with the S key. You can now close the project settings window and return to the script screen. Return to the script view by clicking the script button in the middle of the top bar. In our process function, we now want our script to listen to all 4 inputs instead of just forwards. We create a variable called input and tell Godot it is a vector 3 containing the 3 directions the player can move: left and right on the x-axis, up and down on the y-axis, forward and back on the z-axis. Adding movement like this is a common task in Godot, so there is a helpful function built in, the getAxis function. This function returns -1.0 if the first input event is detected, 1.0 if the second input event is detected, and 0.0 if neither or both events are detected. So, for the line input.x equals input.getAxis, move left, move right, this code sets the x value of our 3D vector to 1.0 when we press the D key, or -1.0 we press the A key, otherwise leaving it at 0.0 if neither or both are pressed. After we get both of those axes, we are left with a vector 3 that can move our player in 3D space when they push the W, A, S or D keys. Running the level scene now will let you move the player around on the little platform. You may notice the movement is a little floaty. We can rectify this easily. Head back to the editor. Select the player in the scene tree and look in the inspector. Under the linear drop-down, find the damp option and set it to 3. Now, the player will lose velocity as they move, to linear damping. The higher this number is, the more forces will dampen. In third-person games, the camera is typically attached to the player and pivots around a point on them to keep the player in frame. Typically,
Okay, pausing because we have reached the end of that section, which is about adding WASD controls. This is Banana. She is my roommate's cat. She's very sweet. And also, the closet in this room connects to another room in the house. So even when this door is closed, she can get in through the closet. She is purring, is what you call it in English. Hi, Banana. Everyone in chat is saying hi. P-U-R-R-I-N-G. Purring. Okay, I'm now going to set her free so I can finish my coding. She does not want to go. So she's going to hang around. Okay, she's now just hanging out in my desk. You might see a tail here and there. So what we are doing is star of today's stream. I know, she's adorable. Okay, she's going back to the closet. Which I'm proud of her for getting through, because that area is filled with all of my like boxes and like moving prep stuff. But I'm glad that she stopped by. Okay, so what we are going to do is we are going to, how old is she? She is, I actually don't know. Again, she's my roommate's cat, so I spend a lot of time petting her and giving her attention. But I think she's like 3 or 4. Vivian Unicorn, thanks for the follow. Ugh. Another thing about moving is that I will no longer be able to see Banana every day. So I'm glad she stopped by. This is the last stream from this home. So I'm glad that Banana stopped by. That's actually making me a little bit teary at that's... Oh, I'm gonna miss her. Okay. If we scroll back and we look at the code that we have just implemented. Great. So what we did here is... Oh, you think it's your room slash desk slash house. So silly, human. Yeah. Yep, it is. This is her world. I am just living in it. And yeah, all of the O's, Shem, I entirely agree. I, again, am like close to tears trying to think about that because she is such a lovely cat and I love her so much. I will still probably see her on occasion, but it'll be hard not like seeing her every day and having her like come into my room and just like say hi and want to be held and pet. Okay, before I get too emotionally distraught, let's go ahead and in our project settings, we're going to open up our input map, which is what I talked about before. And we're going to add a new action that we're going to call move forward. We have move backward, move left, and then we have move right. And for each of these, we can add, again, that input. So move forward is going to be W, where I just have this right here selected, and I just press the button. So W, move backward, S. Thank you, Shem, for the virtual tissues. Move left is A, so we're just going to press A, and then move right is going to be D. So now we've mapped the keys on the keyboard to the different like phrases that we're going to use to refer to them: move forward, back, left, right. And we can also, if we take a look at joypad buttons, we could also add D-pad up, one sec, I will answer that in a sec. Joypad, D-pad down, D-pad left, and D-pad right. So that is an example of how we can have multiple things at once. So move left, we've created the action by typing it in here and clicking enter or this add button. And then move left is the A key, because if I can hold my camera up, you'll notice that we have, oh, it's not going to focus on its own. Let me switch to just talking and see if I can focus this. Oh, it's mirrored. Okay. Let me just find an image of this on the internet and we'll talk about it. Okay. So, if I... If we take a look at the keyboard here, we can see that WASD in this image is red, and that is showing basically that it makes a set of arrow keys, where W is forward, A is left, D is right, and S is down. And the reason, it used to only be that you would use the arrow keys, but then with the advent of 3D gaming and games like, I believe it was the game before Doom. Quake. I thought Quake came after, but maybe it was like Quake 2. Okay, no, it was Doom. Oh, wait, no. Wolfenstein 3D is the game that I'm thinking of. Is the first game where you are moving the camera with the... Well, not the first game, but like a very popular game that is generally credited with this, where you are moving the camera with the mouse, so you needed your right hand to be on the mouse rather than the arrow keys. And rather than have your left hand cross over your body to get to the arrow keys, we use WASD instead. So that is why we set these keys specifically the way that they are. You can also set the arrow keys in this menu in the same fashion. So that is that first step. Now we're going to go back to our player, and we're going to go into our script editor, and we are going to replace the sample code right here with var input equals, and I do not remember what this colon equals specifies, so I will Google that in a sec, unless someone in chat beats me to it. Colon equals vector 3.0, and the point of this is to create our three-dimensional vector, but it starts at 0 because we aren't moving in any direction. And then we are going to set the x-axis of it, so input.x, because it's a three-dimensional vector, to input.get, I wanted that with a capital I, Godot, input dot x, oh wait, no, input.getAxis. Get, oh, I can type so much better when I'm not live, because then I'm self-conscious. Okay. And then we have move left and then move right being what is on our x-axis. And then our z-axis is going to be move forward and move back. So input.z equals input.getAxis. Move forward and move backward. And then we're going to apply this by apply central force like we did before, input. So this is our vector that includes both forward and backwards all in the same thing, times 1200 times delta. Now I can look at chat and see if we have questions. You also did something after setting letters. Okay, I will look at that in a sec. Let me save this and make sure that it works. We're going to go into our level. We're going to hit play. And hey, okay, I can move us around and accidentally fling us off the platform. So, let me save this. We have 5 minutes. This is where we're going to be ending today, and we're going to finish this up on the 14th. Project settings. I then just click OK. Elena, that is the last step. And it adds it. So plus type OK. Can you give us the code, please? Sure. In this case, the code, this is the entirety of the code. And the JEOSTHH. I do not know what that means. I apologize. Actually, I'm just going to copy this one function, and I can probably, let's see, is Twitch chat cool? Can it do markdown support for code blocks? I hope so. No, that's awful. Okay, I'm going to make a paste bin for this. Infamous dimmer words of making a paste bin. I've gotten better generally. Okay, after I paste the code. Okay. Great. Oh, next stream is canceled, so you can relax a bit. Thank you. That is the paste bin for this code right here. I'm going to give you time to do that and then ask questions. Supankar, great session. Thank you. Can you share the code? It is at that paste bin, which is this function, which is really the only code that we've written. But again, I will share this tutorial in chat. And I'm also going to, before I forget, add it to the description of the YouTube recording. So I can show this to you right here. Under settings. Here we go. Under our description, the tutorial that we were following was kaboom. So now that link is also going to be in the recording as well as chat right now. So you'll have that for the future. Again, we are going to finish this up. I thought that we could get through 48 minutes, but I spent too much time talking. Lati, I got my player to move around after messing around with the input map. Thanks a lot. Oh, I'm so glad that that worked. I'm so glad that that worked for you. Yeah, we're going to be finishing this up on the 14th. Elena, so in project, there is that thing. If you can specify what that thing is, I'm assuming you're typing it right now, but I just want to make sure I say it. I will answer your question. Shem asked, tangent question, can I buy a controller to hook up to my MacBook Pro to play Tetrio? Yes, you can. This is where I will open up eBay. And I would recommend a DualShock 4 controller. And if we sort by time ending soonest, we can see that there are controllers that, like this one ending in 40 minutes, 25 bucks. Oh, it's 4 parts only. This one right here in 3 hours, currently $13.50. You can connect this wirelessly over Bluetooth, or it has a micro USB. Yes, it has a micro USB. So you can do either. And then also the reason why I'm specifying this, because you could also use an older Xbox controller, but older Xbox controllers work on the newer Xbox, so they're generally worth more, whereas PS4 controllers don't work on the PS5. And also they have this touchpad right here, which will work as a touchpad to control your mouse on your computer. So generally this is what my like go-to recommendation would be. It also has, I believe, gyro control. So if you're ever emulating an old game console that had that. This is me speaking personally. I would recommend that. Green Yoshi X wants me to call you a cheater if you use this technique. Call you a cheater if you connect a controller to play Tetris? I mean, I'm 1000% certain that other players use it. I don't see the difference, but I respect Green Yoshi's strong opinions. I also... This is me speaking as an individual, not as a representative of MLH. I've had good experiences with Gold Star Tech. I actually bought a controller from them like a month and a half ago for this exact purpose. And it had a problem with the analog stick where like this part was cracked and chipped, so it stuck. And the return process was super easy. They're super kind. Again, that is me speaking as an individual, but also very well reviewed on eBay. So if you do want a controller, highly recommend that. Okay. It is 6:01. I'm going to stick around until 6:05. After each letter, there is something GO or JEO or something. Ah, I understand what that is. It is your keyboard type. So under project settings, if I add test and I add something, you'll notice that right down here it says position on US QWERTY. I believe that depending on your keyboard, if you have a non-US QWERTY layout keyboard, that is what that is specifying. Let me double check this. JEO keyboard. Yes, JEO is a specific keyboard layout, which looks like this, which is, I've not ever seen this before, actually. But if your keyboard looks like this, QGMLW, then that is what that is specifying. If it is GEO, yeah, I believe it is JEO because that is what your keyboard layout is, or that is what Godot thinks your keyboard layout is. Very old keyboard, totally fine, but I think that is what is causing that. If your keyboard looks like this, change it. I mean, I don't know if you're saying to change your keyboard, which, I mean, having a nice keyboard is a nice thing. Good and attentive walkthrough, thanks. I'm so glad that you had a good experience. Generally, I like doing this way of streams, of having the tutorial video and then going through and answering questions, because I feel like it gives you the best of both worlds, of all of the information has been edited and is like perfect, and also you have someone to ask questions to and bounce off of. Feel free to do it as whatever is necessary. We're all friends here having fun. Green Yoshi X is not serious. I do know I don't do Tetris mini events very frequently, but the few times that I have gotten absolutely smoked. There are some people who are extremely good at Tetris. I know I spend too many hours playing against folks I don't know. I love that so much for you. I also realize that I'm still slightly out of focus. There we go. Okay, with that, it is 6:05 p.m., so I'm going to head out. Thank you all so much for coming. This has been a wonderful stream. I hope you've learned something about Godot. Again, we're going to be finishing up this project on the 14th at when? Let me look to see when that is in the schedule. Somewhere on my tabs I have the schedule. That would be day 6 at when? Do I have my schedule wrong? It is going to be day 5. Wait, no, day 6. Yes, it is day 5 on the schedule, but it is 9 a.m. Eastern time on the 14th, implementing a pathfinding AI in Godot game engine. I'm going to drop that event link in chat so y'all can come back for part 2. But again, the recording has the tutorial link in the description, so if you can't, you can always see the recording on YouTube and also follow the tutorial. Good luck with packing. Hug Banana. I will hug her so many times, and thank you for the luck with packing. Thankfully, I don't have many possessions, so it should be fairly easy, but moving is always a process. Great to work with you, Dimmer. I was too involved to rickroll your stream. Thank you, Pharaoh. That is really meaningful, actually. I had a really rough day today, and I was at work 9 a.m. until 3 Eastern time, and then I drove right home and came to stream, so that's why I've been drinking weird things and trying to keep going. And this was a really great stream, and it was really nice interacting with y'all. This made my day so much better, and I hope it made yours better as well. So until the 14th, happy hacking, and have a wonderful rest of your day. Bye, y'all. Oh, I think I just found a new hobby. Thank you for sharing this. Oh, that makes my day even better. Oh, I love sharing game development with people, because I think it is a very fun way to get into computer science that is just a lot more creative. So, okay. Bye, y'all. I really need to go so I can make sure I pack and all that. But, thank you so much for coming, and I hope to see you again on the 14th at 9 a.m. Eastern time. Happy hacking, y'all.